So, in fact, we finished the force and pressure topic in CBSE, and I'm just moving into ICSE syllabus in 8th standard. And in fact, I've put it in force and pressure, but the idea is to discuss about fluids, in fact, states of matter, right? So we're going to look at solids, liquids, and gases, but we're going to explain why there is pressure, what causes pressure, right? What we are also going to look at some things like surface tension. What does surface tension mean? Which is a property exhibited by liquids. We are also going to look at buoyancy, right? Which is in fact we'll go through what you call Archimedes principle, which explains buoyancy, and so we look at all these various things, and I've put it in part of force and pressure because it's really part of different behaviors of liquids, right? So that's why I just put it as a part of that. So I'm going to first start off with discussing kinetic theory of matter, right? So the kinetic theory of matter. What is kinetic theory of matter? Anything which occupies space and has mass is called matter, right? Anything. So solid is matter, liquid is matter, gas is matter. The reason is because it occupies space and it has mass, right? So only thing is they are in different states of matter. So we have solid state, liquid state, and gaseous state, right? And different materials may be in different states based on the pressure and temperature. So if you look at ordinary atmospheric temperature, water will be in solid state below 0 degree, between 0 degree and 100 0 degree and 100 degree it will be in liquid state, and 100 degree above 100 degree it's going to be in vapor state. So same material which could be in different states of matter, right? So but ultimately it is matter. So any substance which occupies space and which has got mass is matter. Now Indian philosophers has defined all matters made of Panchabhutas. Panchabhuta, 5 elements. Any matter is made of 5 elements. Akash, which is sky, right? Vayu, which is air. Tejas, which is fire or energy. Either is basically what you call space, right? So Akash is space, right? Vayu is air. Tejas is fire or energy. Up, which is water, and Kshiti, which is earth, right? So this was the thought process which Indian philosophers, and this was defined maybe beyond 2000 years ago, right? So you can find it in our scriptures that these are the 5 any matter is composed of these is made of these 5 elements, right? Of course it's a very primitive thought, right? Later on we have got into atomic theory of matter. We have explained, we have understood matters contain molecules, atoms, atom contains electrons, protons, neutrons, and a lot of things, right? We have understood a lot more about matter, but this was our ancient thought that India had. Then the first scripture and the first scientist or philosopher who told that there is something called an atom existing inside a matter was Rishi Kanada, right? So Rishi Kanada was the first who suggested all matter, padarth. In Sanskrit, any matter is called a padarth. All matter, which is padarth, irrespective of its physical state, that means it doesn't matter whether it's solid, liquid, or gas, are composed of small particles called anu, right? So are composed of small particles called so are composed of small particles called anu, right? So or atom. Anu is nothing but atom. So Rishi Kanada was the first, one of the first who suggested that, and you can find it in Indian scriptures, right? Now, okay, so that is basically some of the contributions which Indian scientists or philosophers did. Rishi Kanada told this probably in, I don't know, 400 BC or something, right? So now, and in those days there was no way of experimenting. There was no microscopes available. There are no electron microscopes. There are no big complicated equipments that has been invented. So this was totally based on intuition, right? Intuition is basically logical thinking, right? By logical thinking, Rishi Kanada felt that all matter should be composed of Anu, right? So that logical thinking is what basically it is. Just a moment. What has happened to this? Let me just open this again. Just a moment. Seems to be a bit slow. Okay, so Anu, atom, right? Just a moment. Okay. All right. So that is basically what Rishi Kanada told. Right now, let us just move forward. So in Indian philosophy, Kanada was the first to systematically develop the theory of atomism during the 6th century BC, right? So, and it was further elaborated by Buddhist atomists Dharmakirti and Dignaga during the first millennium, first AD, right? So we have got almost more than 2000 years of history where the Indian scientists or Indian philosophers have spoken about the notion of an atom in matter. Then Pakudha Kakkayana, right, in 6th century BC, Indian philosopher and contemporary of Gautam Buddha, right, had also propounded ideas about atomic constitution of material world. So this was somewhere near when Rishi Kanada was there. There was also this Pakudha Kakkayana, another philosopher, who had also proposed, right, who lived around a time when Gautam Buddha used to live, right, quite some time back. The last minuscule particle of the matter that could not be subdivided further is called Paramanu. So the last part, so every matter is composed of Anu, and under that there is Paramanu, which cannot be subdivided further, right? So these are all thoughts which basically our philosophers came to. These philosophers considered atoms to be indestructible and hence eternal. So the atoms cannot be destroyed, right? They exist forever. They're eternal. They exist forever. That was the theory that they had propounded, right? Vaisheshika school of philosophers believe that atom was mere point in space, right? So what I wanted to just tell you is that think about the richness of thinking which was there among our philosophers and scientists, and they had, without any of the equipments, using logical reasoning, they came out with these theories, right, which now we are finding is true. We find that through intuition, right? So that's what basically I want to tell. So that's about the ancient philosophy and what ancient philosophers did, right? Which, if they could do it 2000 years back, I'm sure that each of you can do wonders for our country and this world, right? It is all a question of believing in yourself, right? Okay, fine. So now let us get into some definitions. I think we have gone through these definitions when we discussed about elements and compounds last year. If you want to look at elements and compounds, please in chemistry you can go through my video and which I prepared for 7th standard. Very good description about elements is there. I've discussed about periodic table and a lot of things. If you want to have a better understanding, please go through the elements and compounds if you want to understand elements better. So what is an element? Element is defined as a substance which cannot be subdivided into simpler substances by any chemical means. What does this really mean? Right? Let us take an element, iron. Iron is an element, right? If you take an atom of iron, I cannot subdivide that further. If I subdivide it, if I remove some electrons out of iron, if I remove some protons out of the iron atom, it is no more iron, it becomes some other substance, right? So I cannot in any way change the atom of the iron if it has to exist as iron. As soon as I subdivide, I split that atom into two different atoms with half electrons going to one atom, half electrons going to another atom. If I do that, like how, yeah, so if you look at, let us take sodium, right? Sodium I think has 11 electrons and 11 protons, right? Assume if I take a loaf of bread, I cut it into two pieces. What will those two pieces be? Those pieces will also be bread only, right? But that is not true with atoms. If I take one atom of sodium, I somehow has got some magic knife, okay, using which I can cut that atom into two pieces, where 5 electrons go to one piece and 6 electrons goes to another piece. 5 protons go to one piece, 6 protons go to the other piece. Huh? No, I am just see it's not, you cannot do such things. I am just saying. So I am saying that assume you are somehow able to get one sodium atom, and somehow you'll divide that sodium atom into two pieces somehow. Then what will happen? Some electrons will go to one piece and the remaining electrons go to the other piece, correct? Then what happens? You have two atoms being created, one which has got 5 electrons, another which has got 6 electrons. But in that case, those two atoms are no more sodium atoms. Those atoms are of some other element. Why? Because if it has to be sodium atoms, it should have 11 protons, it should have 11 electrons. So that means atom of an element cannot be subdivided. If it is subdivided, it is no more, the atoms which are produced after division are no more the atom of those elements. For example, so these kind of things happen. There is something called nuclear fission, right? There's a process called nuclear fission where you can subdivide atoms of elements, but the new atoms which are produced after subdivision are no more the atoms of the initial element. So always you should understand the atoms are the smallest possible particle of matter. It just can't be subdivided. So atoms cannot be subdivided, cannot be split into pieces, right? So an element is defined as a substance which cannot be subdivided into two or more simpler substances. So if it is a sodium element, it is a sodium element. It cannot be subdivided into again some two other pieces of sodium. Okay, so elements are those things which cannot be subdivided further. That is what it is. Whereas compounds can be subdivided. Why? Because compounds are produced after when two elements react. So if you look at a molecule of a compound, it has got elements of multiple atoms, atoms of multiple elements. So it is possible to split them, right? But it is not possible to split the atoms of an element, right? So that is basically what I'm saying. What is an atom? Atom is defined as the smallest unit of an element. The smallest. So any element is composed of millions of atoms. So if I take a piece of iron, That piece of iron has got several millions and billions of atoms of iron. Any element is composed of atom. Any element, right, is composed of atoms. So and they are the smallest particle inside an element, right? So atom is defined as the smallest unit of an element, which may or may not have independent existence, but always takes part in chemical reactions. Now, what do you mean by may or may not have independent existence? Most of the elements cannot exist by itself. If I take a sodium, if I take a small piece of sodium, pure sodium, it has got sodium atoms, immediately it will react with oxygen and become sodium oxide. Right? So that is the way it is. So typically most of the elements don't stay, it cannot stay independently. Usually it immediately reacts with some other elements. But there are certain elements which are called inert gas, inert elements. Right? So just switch off the fridge, no? So there are elements called inert elements which don't react with any other elements, like neon, xenon, right? All these are examples of elements which don't react with other elements. So actually, so there are elements like neon, right, and so on. These are called inert elements which don't react with any other elements, right? We say that those elements are in an octet state. We'll see that later on when we look at atomic theory. We'll explain why some of these elements don't react, like neon and xenon and all that. There are some elements which don't react at all, but all the other elements usually don't remain independent. They immediately react with other elements, creating compounds, right? So that's what basically this meaning is. So the atoms are defined as smallest unit of an element, which may or may not have independent existence, but always takes part in chemical reactions, right? So that is about atoms. Now what about molecules? Molecules are smallest unit of matter. If you look at any material, let us take steel, it has got molecules, right? Let us take common salt, which you use for cooking. It is again has got molecules, and that molecule, each molecule has sodium atom and chlorine atom, sodium chloride. Pen also has molecules, absolutely, right? So if typically matter is composed of molecules, and each molecule is composed of multiple atoms, right? Each molecule is composed of multiple atoms because that molecule has been created because of chemical reactions between multiple elements, right? So let us take an example of common salt, the cooking salt that we use. It is basically its chemical name is sodium chloride. So it is the salt has got molecules of sodium chloride, and each molecule has got one sodium atom and one chlorine atom. So matter is usually created because of chemical reactions happening between elements, right? So so matter is composed. So the smallest unit of matter is molecule, and each molecule may consist of two or more atoms of elements, right? So and can retain complete physical and chemical properties of matter. So the physical and chemical properties of matter is really dependent on the type of molecule the matter has. So for example, is it going to be in liquid state? Is it going to be in solid state? Is it going to be in gaseous state? Is it going to be magnetic, right? Is it going to be all these kind of properties that you see, right? Is it going to be shining when light falls on it? All these properties that you talk about, the physical properties of the matter, that in fact is decided by the type of molecule that matter consists of. So the type of molecule that matter consists of is the one which in fact decides on what kind of physical property will that matter have, right? So how all these dependencies, we will discover that slowly as and when you learn more and more science, you will start discovering this more and more, right? How does this molecule influence? The characteristics of molecule in the matter influence the physical and chemical properties of the matter. We'll learn that in the course of time. Don't worry about it. So I hope you understood what are elements, and I'm sure that you would have also heard about what you call periodic table, right? Periodic table is a table of all the elements that. Yes, absolutely, which is discovered until now. So I'm talking about elements. Yeah, so we have discussed about elements. We have understood elements is composed of atoms. We have discussed about molecules. We have understood that matter is composed of molecules, and each molecule is consists of two or more atoms. Multiple atoms. Two or more. Multiple is two or more, right? So that is what it is. Now, now I want to actually explain another concept. Atoms and molecules are in state of motion. You know, everywhere, inside solid, inside liquid, inside gas, in all these states of matter, the molecules which are there inside the matter is always continuously moving, right? I take a perfume bottle, spray some perfume here. After 5 minutes, you enter the room there, right? On that end of the room you stand, and you ask me, "Hey teacher, did you spray some perfume?" Then I say, "Yes." "But I I sprayed the perfume here. How did you know? How did you get a smell there?" How did that happen? Because the molecules are moving. So since the molecules are moving, the molecules are spreading across this room, and those small molecules have also reached that end of the room, and some few molecules got into your nose, and your nasal membrane sensed those molecules, and that's how you got the smell. So this is a simple example which shows that molecules move, right? So that's how the smell spreads in a room. What happens when a spoon of salt is put in glass? If you can try it at home, take a glass of water, take one spoon of salt, put it. Initially you will see that salt is there below. After half an hour, if you come and see, you will see that salt has vanished. Where has the salt gone? Then the scientist in you will say, "Oh teacher, you know what? That salt is dissolved in water." What does dissolution mean? How does the dissolving happen? What is happening is the molecule, there are spaces between the water molecules, and the sodium chloride molecules are going and sitting, occupying those spaces between the water molecules, and it is spreading into the water molecules. I want to show you a small visual animation which in fact shows what really happens. How does the dissolving of salt in water happens? You can see this video, and some of these things it may not be clear. You don't worry about it, right? I just want to quickly show you the animation. So you can see this is how So this is how the common salt, see, this is how the common salt inside looks like, right? And it's an arrangement of multiple. So this is the chlorine atom, and this is a sodium atom, right? And they're arranged like in what you call a crystal, in a crystal form, right? So absolutely right. Yeah, sodium is positive charge and chlorine is negatively charged. Correct. Same number of atoms. Yes, correct. Otherwise, the charge will not be neutralized. No. So so you can see how it is organized. It is arranged like as the form of a crystal. This is what is called a crystalline structure, right? Where this is the way the sodium and chlorine atoms are arranged. Now, what really happens now? Let us look at later on what really is happening during the process of dissolution, right? You can see. Okay, sorry. Now you can see what is really going. Oops. Just a moment. So you can see what is really going on. See, what is happening is. Yeah, let us look at this. Yeah. So now look at what is going on. See, the chlorine atoms is going between the some water molecules. The sodium atom is going between some water molecules. And like that, after some time, this is what has happened. The whole sodium atoms and chlorine atoms are distributed within water. Did you see that? So that is again because of movement. You can see the water molecules moving, sodium atoms moving, chlorine atoms moving. It is, the whole thing is in motion. Yes. So you can see that the whole, all molecules and atoms and all that are all in motion, continuous motion. So don't think that inside the solid all atoms are standing without any movement, liquid without any movement, gases without moving. No, that's not the way. Everything is moving, right? So that is what is basically going on. So you can see here again, right? Correct. So I want to just show you here. See, now you can see this is solid. In solid, what is happening is that the molecules are the molecules are, it depends. So molecules are kind of vibrating. Molecules are vibrating. They are not moving away from each other, right? But they are vibrating at one position, like simple harmonic motion. One point, they are like that. They are vibrating, right? You can see that they're vibrating. Whereas if you look at liquids, there is a lot of movement, right? They are loosely packed, yeah, and so there is a lot of movement, and so that is why if you look at here, the molecule is not moving from his mean position. That is why the solid retains its shape. It has got a shape. It is not that one molecule which is here after some time is there. If that was the case, solid also would not have had shape. But if you look at liquid, the molecules can move around, right? But it cannot move around where it can just move to any place. So it can take a shape, but it has got a fixed volume, right? Because the molecules are still having some attraction with each other. So it cannot simply move far away. But if you look at gas, you can see simply can move randomly to wherever it wants. So that's why gas can spread into whatever space is given. So gas doesn't have fixed volume. Neither it is shape. The gas can take the volume of whatever container it is. No, not necessary. Chlorine is not invisible. It's got a yellow color. So gases need not be invisible, right? But yeah, but gases if you if you look at solid has fixed volume, fixed shape. Liquid takes the shape of the container, but it's got fixed volume, right? Assume I pour water into a large tumbler. Will it take the full volume of the tumbler? No. It will take whatever volume it's supposed to take. If it is 2 liters of water, correct. If 2 liters of water means it will take 2 liters volume. But if you take a gas and put that gas into this container, it will fill the whole container. Right? Now, why is that happening? This is the physical properties of different states of matter because of the way the molecules can move. I told you, right? The state of motion. So in the case of in solids, they are very closely held and they are attracted to each other. So the molecule simply cannot move wherever it wants. So it just vibrates at one position itself. That is why solid has a fixed shape, right? Whereas liquids, they can move around, but they cannot move just really far away. They can move around. So that is why it's got a fixed volume, but it can take any shape. Whereas gases can move randomly to wherever it wants, right? And so in that case, it's very, very loosely held, right? There is no attraction between the molecules. And because of that, gases don't have a fixed volume, neither has a fixed shape. So it is because of this property, the kinetic theory of matter. So I'm explaining the kinetic theory of matter, and kinetic means motion, right? So here you can see the motion of all these, the how the molecules can move in the case of a solid, in a liquid, and gas, and how it is influencing the physical properties. Is it clear? Yeah. So what happens when a so I told you how the dissolution of dissolving of salt is happening in water, right? And how the salt molecules are kind of moving around and taking.
Molecules are taking those salts.
Yeah, absolutely correct. Salt disappears after a while, and we've seen why that is happening. Now, let us look at arrangement of molecules in matter. How is it? How are these molecules arranged, right, in matter? Molecules are in state of continuous motion. You have seen that, right? I showed you how these molecules are moving in the case of a solid, in the case of a liquid, and in the case of a gas, right? So, and they possess kinetic energy. Kinetic energy is the energy because of motion, right? Kinetic energy is energy because of motion. So all these molecules are having kinetic energy because they are moving continuously. Because solids, they are vibrating in the same position, but in liquid it can move around, but with some restrictions, whereas gases, it kind of can move around to wherever it wants, right? So now, why is it that in the case of solid it can only move a little, it can only vibrate? It's because
They're very tightly packed.
tightly
There's
packed,
a lot
a lot
of interaction.
of attraction. There's a lot of when this molecule is trying to move a little this way, this molecule will pull it back, right? When it, you understood? So there is lot of intermolecular force of attraction in the case of solid. As intermolecular force of attraction is very high in the case of solids, right? So that is why the solids, they have a fixed shape, because the molecules cannot move from its position. It always is in that position, it just vibrates there. So kinetic energy increases when temperature and with temperature, and decreases with temperature. Kinetic energy increases with temperature and decreases with temperature. I want to just show you a small simulation here, right? So here what I have is, let me take oxygen, or let me take water. So now this is water, right? So now this is below 0 degree. Water is below 0 degree, which means it is ice, solid.
Very solid.
Yeah, so it is solid now. So all the molecules are closely held to each other, right? And they are just vibrating. They are just vibrating, right? They are not able to move away from each other, are they? No. So this is ice. Now what I'm going to do is I'm going to heat it, right? I'm going to heat it. I'm going to apply some fire. Temperature is increasing. Now it is above. Now it is above 0 degree, between 0 degree and 100 degree. Now what is happening? The molecules are able to move away from each other. It is water, right? Molecules are able to move away from each other, and you can see that some molecules are going out. So it's liquid state now. Water is in liquid state, right? Don't you see that?
Yeah.
So now that is what's going on. Now what I'm going to do is I'm going to heat it again. Let us take it above. When it becomes 373, it is going to be gas. See, now it is gas. Now random motion, right? It is random motion. It is all going away from each other wherever it wants. Random motion it is doing, right? And now if I start heating more, so when the speed of motion is increasing, that means kinetic energy is increasing. I'm applying more fire, right? More heat. Now you see, its motion starts becoming really fast and moving. Kinetic energy is increasing.
And if you make it extremely cool.
Now I'm going to again reduce. Let us see what happens. So I am now making it cool. Okay. Now temperature is reducing. Now it has become liquid again. It'll again.
No, make it extremely cool and show.
Yeah. So it's become solid now. Right? So now it's ice. So you see what is really happening. As and when I am applying, increasing the temperature, the kinetic energy of these molecules are increasing, and because of it, it starts kind of moving, right? And you can see now it is solid state, and when I apply more heat, when it goes above, now it is liquid state, it is moving around. It is not simply moving far away from each other, but it is still moving. Huh?
Because it has fixed.
It's fixed volume, that's right. But it is still moving within that fixed volume, it is moving now.
One or two molecules over here and there.
Yeah, that will happen. That is because of slight vaporization, right? Slight vaporization still can happen even at below 100 degree. Also, water vaporizes, and that is why those things are going up. Now when I apply heat, now it is vapor, water vapor. You can see complete random motion, right? So you understand? Did you understand this? So this is what is really going on with molecules, and so you can see now here's the same material, water, and you can see when it is cold, when it is below 0 degree centigrade, you can see it's a solid state. The molecules are simply vibrating, right? And when it went above 0 degree, it became liquid. Molecule starts moving around, but it's still in a fixed volume, so it's constrained movement, but it does move from its position. And when it went above 100 degree, it vaporizes, and now you can see what is happening. It's complete random motion of molecules, and it is occupying the complete volume of the container, right? So this is basically what I want to show you. I hope it is very clear what is really happening. Okay? And so that is what I was saying. So when the temperature is increasing, the kinetic energy of molecules is increasing, and because of the kinetic energy of molecules increasing, it starts moving more easily.
More the kinetic energy, more the molecules move here and there.
Yes, absolutely. So that is basically what is going on. Now, one thing you should understand is the molecules inside matter do attract each other, right? They attract each other. There is force of attraction between similar molecules, and that is what is called force of cohesion. So why in the case of solids the molecules are in that position is because of the force of cohesion, right? The molecules of the same material is attracting each other, right? Whereas there can also be attraction between different kinds of molecules. That means it is possible, for example, when the water is poured into a container of glass, there could be attraction between water molecule and gas molecule. That is also possible. So attraction,
There can be an attraction between
same kind of molecules or different kind of molecules. Both are possible. And the attraction between different kinds of molecules is called force of adhesion.
so when we will take a water in a container, then after that we put some potassium permanganate, and then after that there will be interaction between the water molecules and that.
Yes, interaction between water molecule and potassium permanganate, and you can see potassium permanganate moving around in the water, right? And there could be attraction which could be there between the water molecule and the potassium permanganate molecule. So what basically I'm saying is there could be attraction between same kind of molecules inside a matter. There could be attraction between different kind of molecule when two matters are coming in contact. So we'll actually look at force of adhesion later on. I'm going to discuss about what you call meniscus, right? And when I discuss about liquid meniscus, I will actually explain about what is force of adhesion. So what you should understand is molecules do attract each other. And so that's what we saw even in that simulation. You saw that when it is in solid state, how the water molecules are attracting each other, and hence they're closely held and they are not able to even move away from each other, right? And that is because of the force of cohesion, or what you call the intermolecular attraction, right? Force of attraction. Now, empty space between molecules is called the intermolecular space. So let us go back and see that simulation, right? Let me reduce the temperature. So here now this is in solid state, and you can see there is space between. They are all vibrating, and there is space between, right? There is space between these molecules, and that is called the intermolecular space. So this space is what you call the intermolecular space. You can see that space here, right? So all these spaces. So you can see the space, the space, the space. So there is space between the molecules, and that is what is called intermolecular space, right? So all matter has got intermolecular space. Between the molecules, there will be space, right? Is that clear?
What is this?
No, nothing. Let's go back. And the empty space. So the force of attraction between molecules is called intermolecular force of attraction, right? So between the molecules, I told there is force of attraction. So if you look at here, why these molecules are not moving away from each other is because this molecule is attracting this molecule is attracting this molecule, and so on. So between the molecules there is a force of attraction. That is what is holding all molecules at their place, right? So that force of attraction between molecules is what is called intermolecular force of attraction, and it can be because, and so both adhesion and cohesion that I explained about, both of them are because of this intermolecular force of attraction, right? So I hope you understood the intermolecular force of attraction. And intermolecular force of attraction increases as intermolecular space increases. So if you look at what is really happening, so when I apply heat, now what is happening is the intermolecular the space between molecules are increasing now. See, don't you see that? And when the space between molecules are increasing, the attraction between them is decreasing.
And when you put it extremely hot.
Yeah, so when I put extremely hot, it's going to be even worse. Right? So you can see they're like far away from each other, and they are colliding with each other and moving and randomly moving here and there. And why? There is no attraction at all. There's very, very little attraction between the molecules, because the intermolecular space between the molecules is so high, right? So that is basically what I wanted to tell you. So intermolecular space is a very key aspect which is got. So more the intermolecular space, less is going to be intermolecular attraction. Now when I cool down, what is going to happen is the intermolecular space is going to come down. Of course, kinetic energy is reducing and intermolecular space is going to come down, and as and when the intermolecular space comes down, intermolecular attraction increases, and when the intermolecular attraction increases, you can see now it's solid. And now you can see that the intermolecular space is far lower than when it was in gas, and the attraction is far higher, and the molecules are held at their position, right? So this is what is going on. So intermolecular space is a very important aspect that you have to look at. So I hope you are clear about the aspect that the molecules in continuous motion, they possess kinetic energy, and when the temperature is increasing, kinetic energy is increasing. When temperature is reducing, kinetic energy is reducing. There is force of cohesion when there is attraction between molecules of same kind. When there is attraction between molecules of different kind, it's called force of adhesion, right? We'll see what all these means later on. Then between the molecules there's intermolecular space. When the intermolecular space is increasing, intermolecular attraction reduces, right? And so these are some of the points which I hope we are clear. And we also saw how the molecules move in the case of a solid, and the case of a liquid, and the case of a gas. Any questions?
No.
Okay, cool. So we will actually look at how is the arrangement of molecules in solid, right? Now, as we have seen, molecules in solids are tightly packed, right? So if you look at, let us go back here, right? So let's see oxygen. So you can see this is oxygen in solid state, right? The temperature is minus 240 degree, right? So now it is, so you can see how they are, and it's solid state, and which means molecules are closely held, closely packed,
Can
right?
we touch it?
No, how you can touch it? This is just a simulation. This is using graphics, they have simulated it, right? Now when I apply heat, can see that molecules start moving, and now it is in liquid state, right? Now it is in liquid state, and you can see that they are able to move away from each other, but they still are closely held, right? And they occupy a specific volume and so on. So but I just want to show you how it is in solid state, right? So in solid state you can see that they are very closely packed. Now let us look at it. So we are discussing about solids now. So they are very closely packed, right? So intermolecular forces, intermolecular spaces are small, sorry. So if you look at the intermolecular spaces here, is very small. Don't you see that? Right? There's hardly any intermolecular space. Very close, they are very closely packed, and since the intermolecular space is very slow, the intermolecular force of attraction is very very high, right? Because the intermolecular space is very low, intermolecular force of attraction is very high, and that is why they are kind of held tightly with each other, and that is why the solid has got a specific shape, right? Is that clear? Yeah. Okay. Now intermolecular force holds the molecules in a particular point. You can see that, right? So here you can see that they are held at a specific point. They're just vibrating at that point, but their mean position of vibration is not changing. That means each molecule is in the same position. It is not able to move from each other, unlike a liquid. Now as soon as I move to liquid, I apply some heat. Now it is liquid state and it is able to move away from each other, right? And you can see the intermolecular space has increased. So that is what is basically going on. So in the case of solid, the intermolecular space is very small, intermolecular force of attraction is very high, and because it is high, the molecules are held at one particular position. They cannot move from that position. They are just vibrating at that position, right? Okay. Molecules have fixed positions, and hence the solid has definite shape and definite volume. So it is because the molecules cannot move from their fixed position, the solid has got a fixed shape. Because since it cannot move that position, all the molecules are in that position. So what happens? The solid will be having a fixed shape. Yes. Correct? And hence it also got a fixed volume. Correct? Volume. Length. So the space that solid occupies also is all going to be the same. Yeah. Correct? So this is because of this, actually the solid has a fixed shape and fixed volume. Intermolecular force is high, and hence it is difficult to deform solids. It is very hard, right? To break an iron rod is very hard. Why it's so hard? It's so hard because the intermolecular force of attraction is very, very high. If you have to break it into two pieces, you have to get over that intermolecular force of attraction. And it's so high in the case of solids, and that's why they are so rigid and hard. Right? So you can see the molecular structure, or the way the molecules are arranged in solid is a reason why solid is hard, solid has fixed shape, and solid has fixed volume. Is it clear?
Yeah.
Okay. Now what happens to the liquid? Now the molecules in liquids is less tightly packed. It is not as tightly packed as solids, right? And intermolecular spaces are larger than solid, as we have seen already, right, in this simulation, right? So now this is in liquid state, and you can see that the intermolecular space is far higher than the intermolecular spaces when it was in solid state, right? And so because of that, intermolecular forces is less than solid, and that is why the molecules can now move away from its position. It can move to different positions, but it cannot simply move far away. So that is why it occupies a fixed volume, but the molecules can move away from each other, and that's why liquid can take the shape of the container. It doesn't have a fixed shape like solid.
But you should give it a amount of volume.
But it has a definite volume because molecules can move from its position, but it cannot move far away from its position.
Like this bottle here.
Ah.
If you pour
Absolutely. Absolutely. Right? So molecules that make up the liquid are so close together that they resist changes in volume even at high pressure. Even if I apply very high pressure on a liquid, its volume doesn't change because the molecules are not really far away. Yeah, of course, the intermolecular space is higher than solids, but it is not so high where it can simply move to wherever it wants, unlike gases, right? So that is how the arrangement. So now this arrangement of molecules in liquid is explaining why the liquid has those physical characteristics where it can take the shape of the container, but it's got fixed volume. Clear? Okay. Now let us look at arrangement of molecules in gases. So now let us apply some heat here, some more heat, and make it oxygen gas. Now this is oxygen gas. Complete random motion of molecules. They are colliding each other, moving wherever they want, and they have kind of fill the whole container, right?
It is with every gas.
Yes, all gases are like this, right? Intermolecular spaces are very high. Intermolecular, huh? Water vapor is also like that. Water vapor is the gaseous state of water, right? Even there, it is the same thing. We saw that, right? So any gas, this is what's happening. The molecules are all moving away from each other, and they're also the same thing, right? You can see how it is. Neon is actually in gaseous state even at minus 240 degree.
Argon is also the same.
Yeah.
Almost all gases.
Yeah. Okay. So all gases will be like this. They'll have random motion, and the intermolecular space will be very high, intermolecular force of attraction very low, and because of that, it doesn't have definite volume, doesn't have definite shape. Right? So this is basically what is about the gases. So the molecules are far apart, intermolecular forces are very low, do not have a definite shape or volume, fills entire space in which it is enclosed. Right? So these are the characteristics of molecules. I hope that it is clear for you. The explanation and the discussion that we had in kinematic theory of matter. We'll continue discussion on this tomorrow, where we will get into the topic of surface tension and see what does surface tension mean and what are some of the very interesting phenomena which happens because of surface tension. We'll actually look at all that tomorrow. So I hope you had a wonderful session. You had an understanding about the molecular structure. So let me sum up. We talked about what Indian philosophers had thought initially. Then we talked about what is the definition of element, atom, right?
Element, atom,
Molecule.
That we stated the state of motion of different molecules.
Yes.
In case of solids, liquid, and
Gases, right?
And after that, we discussed even about arrangement of molecules.
Arrangement of molecules, yes.
Intermolecular force of attraction.
Yes.
Is very high in case of solid.
Yes.
It is but then after that liquid it is partially low.
Yeah.
And then after that
Gases is very low. And then based on that property, we kind of found their physical properties.
Then more the kinetic energy, less is the attraction of molecules.
Yeah.
And we also.
And when the temperature is increasing, when the temperature increases, what happens to the kinetic energy of molecules? They increase, right? So I think that is what we have seen. Now we will look.
After that, we discussed about force of adhesion.
Yes.
And then after that, we also saw arrangement of molecules in
Yeah.
solid, liquid, and gas. And
Absolutely.